Welcome to this section on AMD and Cisco UCS. AMD and Cisco have been working together for quite a while, and now we're starting to expand this partnership to include AMD's third generation EPYC processors. We're going to see some very cool things coming along that's going to help us be able to deploy our data center solutions more rapidly and more easily. So as the portfolio starts to expand, these are going to be the Milan-based rack servers, followed by other form factors. Initially, we see here, we've already had the C4200, but these Milan are going to be our UCS C225 M6, and our CUCS C245 M6. Very similar in design between our C220 and our C240. Now, one of the key components of this is we are using all this great features, and coming soon will be the Cisco validated designs and all those other things we're used to having. But one of the keys is it's a cloud first architecture. And so we want to be able to manage everything in our data center across all domains, really kind of closing that loop between different teams and help things move faster. This really is going to empower developers and other people to be able to go ahead and automate different solutions. So this is really the industry's first cloud managed infrastructure for computing, which is our Cisco Intersight. So as this partnership continues to expand, and our UCS portfolio continues to grow, adding the AMD based on the third generation EPYC processor is going to offer a huge opportunity. The innovative ways that it has, the different components that make it more efficient in certain manners, we're going to try to understand. But this is a great chance for us to modernize our environment and support a cloud-first architecture. So the hardware portfolio for Cisco has evolved over the years. Many of these probably look familiar to you. All right, the C4200, this is of course the 4 nodes with 2 sockets each based on AMD. Now, many of these, as you know, are going to be Intel based. But let's take a look at the roadmap. As we look forward on the roadmap, we can see kind of that push on some of the AMD. As the new AMD products are going to come out, we're going to see new UCS servers using those new AMDs. So when the next generation comes out, all right, we'll go ahead and that'll be the next generation, our UCS. So during this evolution, we've kind of gone through a couple steps. All right, we started off back when we had Naples, but Rome. Now, Rome's been shipping for a while, all right, 7 nanometers, 64 cores, but now we move up to Milan. We'll talk about some of the difference in Milan. Big difference is it has the Zen 3 core, which goes ahead and really helps us improve performance, and we get significant improvements. And so we'll start looking at the different components and how these things work together to go ahead and maximize our performance. And so this is our Milan, which is going to be our M6 series from Cisco. In the future, this will see the next generation, and of course Cisco will keep pace with that. So when we look at the EPYC architecture, all right, the new one, this is built on the 7003 series processor. It's built on the Zen 3 core and what's called the AMD Infinity architecture. These processors provide a full feature set across the stack with industry-leading I/O, industry-leading 7 nanometer x86 CPU technology, integrated security processor, and so it really is a powerful tool. And as you look at this picture, you notice, you start seeing, oh wow, it provides up to 32 megs of L3 cache per core. And we have memory channel interleaving that helps go ahead and gives better economics and performance in multiple DIMM configurations, synchronized clocks between the fabric and memory, all really driving to a faster, better results in our performance. The naming convention, we'll get you, if you're not familiar with it, first of all, we see the product series. It's going to be our 7000 series. That next number is kind of important. The next number is going to be the number of cores. So you see like a 7700 is going to have 64 cores. And so as you see the different numbers, that'll give you a reference. We go down to the 5. The 5 is going to go ahead and give you a reference on performance. And then we see the 3 here, and that's the generation. Okay, and so this will continue to go ahead and as new ones come out, it'll follow this basic naming convention. Now we support this in two versions. We have a two-socket design and a different one-socket design. This is not a two-socket motherboard with just one CPU. It is a different design to optimize for that one socket. The single socket has become more and more popular in our data centers. So we have kind of this change of going from this, hey, we always need at least two socket processor to get that performance, to when we start seeing the utilization, the use in the data center, and as these high number of core CPUs come out, we're seeing a lot more than one socket. But if the two socket, if you have very stringent compute requirements here, and so it gives you a little bit higher, but the one socket has really become popular, and the AMD EPYC really kind of lends itself to that because of its architecture. It can support a lot of simultaneous processes. And so with the one socket, we get reduced power efficiency, reduced memory latency, some reduced cost, and the single socket has really become popular, particularly with the AMD. So when you start looking at a single socket Intel, right? Like, okay, here's a single socket Intel, here's the two socket Intel, but look at the EPYC with a single socket. That's huge. It's really kind of a great solution for that single socket that we're really able to go ahead and drive such high performance with a single socket solution. What can we do with all this power that's available to us? Well, we target all the different segments you might expect. And so there's a lot of information here, but we can see, our high performance computing, CPU optimized for that GPU acceleration, right? Which is really going to be key there. For the virtualization, VDI, that large number of cores and the large memory capacity is going to support a huge number of virtual machines. In the cloud here, we go ahead, we have more memory capacity, giving us more VMs, all right, including enabling confidential cloud computing. Data analytics, high parallelism, right, with all those different cores, and a lot of I/O bandwidth to help with analysis. And if we're doing data analytics with GPU, we support the GPU as well. And finally, we see last on the end, as far as data analytics and storage, that we have high parallelism, we have very fast cache, all right. We do support memory encryption for security, but we support SATA as well as NVMe. So we have a breadth of solutions that are supported, and a large number of ISVs are working with this solution. So you can see under the operating system, some of the big ones, Canonical, Red Hat, VMware, Microsoft, of course, all right? And we see some of the hardware vendors. We can see a lot of the different components and so much support out there. And that support is just going to continue to grow. Now we have two main solutions with this, which is the 225 M6 and the UCS 245 M6. All right, the 225, we have our single socket solution. All right, so we can go ahead and optimize with that single socket solution. With the 245, it's going to be just the dual socket, right, where we have a choice on the 225. We have sections later that go into detail and really break them down, but when you start looking at the components here, you're going to find these are incredibly powerful solutions. And the big choice oftentimes is going to be how much storage. You obviously get significantly more storage in the 245 than the 225 because of the form factor. So one of the real questions people ask is, hey, when do I choose AMD and when do I choose Intel? Well, like the answer to every question in computing, the answer is it depends. Now this chart will give you kind of a reference, right? And we can see there are a number of things that AMD is really a perfect solution for, and there's some things it's not. So as you're starting to look, this might be a nice reference for you to say, okay, should we consider an AMD solution? Should we lead towards an Intel solution? And so we're really seeing some things at high performance computing, machine learning, and on the data management side, we're seeing a lot of advantages to choosing AMD over Intel. But for certain things, storage-centric collaboration apps, Intel still has the advantage. So AMD and Cisco are working together, creating new innovative products to help you accelerate your data center solutions. Thank you.